Alright, this is Unit 2.5, question 20 from the test prep. It's the limit as x approaches e of x cubed minus e cubed over x minus e. So the first thing you need to know is there's two ways of doing this. You can either do it the more straightforward way, which is by doing the limit, or you can do derivatives, which I'm going to show you next. But first we're going to do it the more straightforward way. So what you need to know first is the difference of two cubes formula. So that is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And this is our difference of two cubes formula. This will let us simplify this limit using that. So I'm going to drop down the limit as x approaches e. And then our a is going to be our x and our b is going to be our e. So a minus b would be x minus e. And then a squared is x squared plus a times b, so x times e, plus b squared, which is e squared. And then that's still all over x minus e. And that will cancel out with that, so we're left with the limit as x approaches e of x squared plus ex plus e squared. And now we can just directly substitute e into x. So we get e squared plus e times e is e squared plus e squared, which will give us the answer of 3e squared. So that's our more straightforward way of doing the limit. The other way to do this is by recognizing that this is just the definition of derivatives. So when you have f prime of a constant c, that's equal to the limit as x approaches c of f of x minus f of c over x minus c. And in this case, our c value is just e. So that we know that this is the same as the derivative of x cubed, because that's our f of x, when x is equal to e. So we can just take the derivative of x cubed, and using the power rule, we get 3x squared. And then if we plug in e, we get 3e squared as our final answer. This is Unit 2.5, question 21. This is a pretty similar question to the last one. I'm going to show you two ways to do it. One is the more usual way of taking the limit, and the other one is using derivatives. So the first thing we're going to know before we even start the problem, we're going to need to want to know the difference of two squares formula. So this is saying that a squared minus b squared is going to be equal to a minus b times a plus b. So now, when we're taking the derivative of a radical, we always want to multiply by the conjugate. So we're going to multiply this by the conjugate of the numerator, which is 25 plus h plus 5. And then when we're doing that, we have to multiply the denominator by the same thing, so that in the end we're just multiplying by 1, so it doesn't change the fraction. So now this on the numerator is a difference of two squares. So we know that it's going to be a squared minus b squared. A squared is 25 plus h squared, which is just, I'm going to drop down the limit, 25 plus h. And then negative 5 times 5, or b squared, will be negative 25. And then on the denominator, we're not going to FOIL, we're going to keep it the same. So it's going to be the square root of 25 plus h plus 5. Now, in the numerator, the negative 25 and the positive 25 cancel. And then the h on the numerator and the h in the denominator cancel as well. So we're left with the limit as h approaches 0 of 1 over square root of 25 plus h plus 5. And now we can plug in 0. We get 1 over 25 plus 0 is 25. Square root of 25 is 5. So we get 5 plus 5, which is 1/10 as our answer. The second way to do this is to know the definition, that this is just the definition of derivatives. So f, when you have f prime of some c value, that is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So we can try to find f of x. That means this equation right here is the same thing as the derivative of the square root of x when x is equal to 25. Because you can see when you plug in 25 into f of x, you get 5, and when you plug in 25 into f of x plus h, you get square root of 25 plus h. So now we can take the derivative of square root of x. So square root of x is the same thing as x to the 1/2 power, and when we take the derivative of x to the 1/2 power, we move the power to the front, so we get 1/2, and then we subtract 1 from the power, so it's negative 1/2 to the negative 1/2 power. And that's the same as 1 over 2, and then we move the x to the denominator because it's to the negative power, and when it's to the 1/2 power, it's the same thing as the square root of x. So now we can plug 25 in, so you get 1 over 2 root 25, which is equal to root 25 is 5, and then 2 times 5 is 10, so our answer is 1/10 yet again. Do you think this is question 22 from unit 2.5 of the test prep? Given f prime of x equals 1 over x and f of 2 equals 5, write an equation for the line which is tangent to the graph of f of x at the point x equals 2. And we have 5 answer choices right here, and the problem is that they're all in slope-intercept form and not point-slope form, which is what we usually work with. So we're going to have to do some extra work. First, we know that the slope of the tangent line is going to be just the derivative when you plug in your x value. So we know the derivative is 2, so if we plug 2 into x, we get 1 over 2. Or we know the derivative of f of x is 1 over x. So if we plug our x value of 2 into the derivative, we get 1 over 2, which gives us our m value. To get our y value, well, it says it right here, f of 2 is 5. So we know our y1 is going to be 5. And for our x1, we're given it right here, it's 2. So our point slope form that we already know and have been working with is y minus y1 equals m x minus x1. But the problem is that this isn't in slope-intercept form, this isn't in point-slope form, it's in slope-intercept form. But let's start by plugging in what we know. Y minus 5 equals 1/2 x minus 2. Alright, well, we can just simplify this algebraically by distributing the 1/2 to both of those. So we have y minus 5 equals x over 2 minus 1. And now we're going to add 5 to both sides. We get y equals, all these questions say 1/2, so I'm going to put 1/2 x instead. And then negative 1 plus 5 is 4. So we're left with y equals 1/2 x plus 4, which is answer choice C. This is unit 2.5, question 23 of the test prep. In the figure to the right, line L is tangent to the graph of y equals x cubed at the point A with the coordinates a, comma a cubed. Line L crosses the x-axis at point B with the coordinates b, comma 0. So here we have a picture of line L. It's intersecting this graph y equals x cubed right here at A, and it's intersecting the x-axis at point B, which is b, comma 0. And we have the coordinates in terms of A and B. Our first question says find b in terms of a. So this could be a little bit confusing, but whenever it says find a variable in terms of a variable, it's just saying find b and then equals something with a. So it could be like a squared or a cubed, just something with a. And that's what find b in terms of a means. So in order to do this, we're going to need to find the equation of our linear line that's intersecting our x cubed. And we know that the line is tangent to the graph, which means that the slope of this line is going to be the derivative of our function. To find the slope, we're going to take the derivative of x cubed. And using the power rule, we bring the power to the front, we get 3x squared. We know that our slope is 3x squared. From this, we can make our equation of the line using points a and a cubed. So y, remember point slope form is y minus y1 equals m x minus x1. So our y1 right here is a cubed, so y minus a cubed equals m, which is our 3x squared, or in this case, we're going to be plugging in a into our x value, so because we're finding the slope at x equals a, so it'd be 3a squared, and then times x minus, and our x value, which is a. So this is our equation of our line right here at the point A. So now, what we got to do is we have to find the value of b in terms of a. So now we just plug b in comma 0 into our y and x. So we have 0 minus a cubed equals 3a squared times b minus a. And from here we can just distribute and solve for b. So we have negative a cubed equals 3ba squared minus 3a cubed. And then I'm going to go ahead and bring this 3a cubed over to the other side by adding it to both sides. So 3a cubed minus a cubed is 2a cubed. So 2a cubed equals 3ba squared. And then from here, I'm just going to divide both sides by 3a squared. So we get b equals 2a cubed over 3a squared. And then from here, I have an a cubed on the top and an a squared on the bottom. So that turns into just a. So b equals 2/3 a as my answer for b in terms of a. And the second part is really easy. Find b when a equals 9. We're just going to use the formula that we had before, but instead of a, we're going to plug in 9 for a. So b equals 2/3 times 9. 9 over 3 is 3, and 3 times 2 is 6. So b is equal to 6 as our answer to part B. And those are our two answers. Alright, we finished with Unit 2.5. Next we'll be doing Unit 2.6.